So let's dive into an element that is absolutely essential for our modern world, especially for our green future. But like any resource this valuable, its story is, well, it's complicated. It's a real double-edged sword. This is the story of lithium, what many now call white gold. And you know what? You're actually holding it right now. Yep, it's inside the battery of the phone, the tablet, the laptop you're using to watch this. It's in pretty much everything. And honestly, without it, our digital lives would just grind to a halt. And there's a very good reason they call it white gold. Its value is just immense, and not just for our gadgets. We're talking about the entire global energy transition. It's pretty much the critical ingredient we need to decarbonize the planet. So, what's the big deal? Why is this one element so special? Well, it's the lightest metal on the periodic table, which is already pretty cool. But its real superpower is that it can pack a huge amount of energy into a tiny, tiny space. That high energy density is exactly why it's the undisputed champion for rechargeable batteries, from the EV in your driveway to the massive battery farms that help stabilize our power grids. And because of all that, our appetite for it is just exploding. We're on track to see a five-fold increase in global lithium demand by 2030 alone, 5 times. An incredible demand like that, well, it sets the stage for some pretty major global challenges. And that surging demand has turned lithium into a crucial piece on the global chessboard. It sparked this fierce geopolitical competition for who gets to control it. Now, this is where the game gets really interesting. You might think the countries that dig the most lithium out of the ground, like Australia and Chile, would hold all the cards. But nope. China has played a masterful long game and now has a strategic stranglehold on the supply chain. It refines and supplies an incredible 70% of the world's battery-grade lithium. That kind of dominance makes other world powers, a little nervous. So they're scrambling to find new sources, and right now, all eyes are turning to Africa. It might only have about 5% of global reserves today, but investment is just pouring in. Projections show that in just a few years, Africa could be supplying 12% of all lithium. It's the new frontier. And what's fascinating is seeing how this competition actually plays out on the ground. You have these two very different approaches. China often pairs big infrastructure projects with deals that give it controlling shares in the mines. The West, on the other hand, is trying a different tactic. Through things like the Mineral Security Partnership, they're funding transportation and negotiating for equal shares, offering a different kind of deal altogether. But here's a crucial point. It is a huge mistake to think these African nations are just passive players in all this. They have their own agency. Look at Zimbabwe. For years, U.S. sanctions limited its options, which opened the door for over $1 billion in Chinese investment. But then, Zimbabwe made a power move. It banned the export of raw lithium, forcing companies to build their valuable refining plants locally, which keeps more of the money and jobs in Zimbabwe. So, that's the geopolitical chess match. But it's really only half the story, because this so-called green transition, it has some hidden costs. And when it comes to lithium, there is a very, very real environmental price tag. I mean, this image really says it all, doesn't it? These are lithium brine evaporation ponds. It's a surreal, almost alien landscape, and it perfectly captures the paradox we're facing. The technology we're counting on to save the planet can have a really dirty start. Just get a load of this number. To produce a single ton of lithium, it can take up to 1.9 million liters of water. That is a staggering amount of water, especially when you realize a lot of this happens in some of the driest, most arid places on Earth. And there's really no easy way out of this. The two main ways to get lithium each come with a huge problem. You can do the brine evaporation, which uses all that water and threatens local communities, or you can do traditional hard rock mining, which takes immense amounts of energy. Energy that, ironically, often comes from burning fossil fuels. So you're polluting to get the material for a clean battery. And the damage goes way beyond just water and energy. The process can absolutely wreck local ecosystems, contaminate drinking water, and create mountains of toxic waste. For the people who live nearby, the dust alone can cause serious respiratory problems. It's a really heavy toll. Okay, so this all brings us to the next critical question, right? We've got these huge geopolitical and environmental problems. Can we innovate our way out of this? Can we actually find a way to make white gold truly green? Well, a huge piece of the answer is recycling. Now, it won't eliminate the need for new mining overnight, but the benefits are massive. Making lithium from old batteries can slash the CO2 emissions from production by nearly 40%. That's a powerful and absolutely necessary step. At the same time, labs all over the world are in a flat-out race to invent brand new kinds of batteries. We're talking about things like sodium-ion batteries, which use materials that are way more abundant and cheaper. And then there's the holy grail, the solid-state battery. That's the one that promises to be safer, last longer, and pack way more power. But here's the thing. Even if we get better, greener batteries for our cars and our phones, there's another, much bigger problem to solve: storing insane amounts of energy for the entire power grid. To make wind and solar reliable 24/7, we need to think way beyond just chemistry. So how do you do that? How do you store energy on that scale? Well, this brings us to a really fascinating and surprisingly elegant solution that just sidesteps the whole battery supply chain mess entirely. It's called a gravity battery. And the concept is just brilliantly simple. Instead of storing energy in complex chemical reactions, you store it as pure gravitational potential energy. How do you do that? You lift something really, really heavy. Okay, so here's how it works. When you have extra power on the grid, say it's a super sunny and windy day, you use that electricity to winch these massive blocks up a tall tower. That's it. The energy is now stored in the height of those blocks. Then, when you need the power back, you just let the blocks come down, their immense weight spins a generator, and boom, electricity flows back to the grid. It's that beautifully straightforward. And the advantages are just amazing. Unlike chemical batteries, these things barely wear out. They could last for decades, they completely avoid the messing supply chain issues of lithium, and they are perfect for storing huge amounts of energy for a very long time, which is exactly what our future grid needs. And this isn't just some science fiction concept. Experts are taking this very seriously. As this quote points out, technologies like this have really strong potential to become a cornerstone of a stable, renewable, powered world. So what this all boils down to is this. Our electrified future isn't optional, and it's going to need a truly staggering amount of energy storage. The big question we have to answer now is, what's that going to look like? Will we perfect the chemistry of batteries, or will we master the simple physics of gravity? The race is on, and honestly, the outcome is going to shape the world for all of us.